Hi everyone! Today we're going to discuss how to utilize Kinco's new servo software, KincoServo Pro, for online auto-tuning. First, open the software. You'll see an online update prompt. Just click Ignore and Continue. Click Online Debug and a communication setup window will pop up. Choose the communication method and COM port based on your actual setup. Set baud rate and station number to auto, then click Auto Scan. Start scanning. Once the scan is complete, any connected servo drives will show below. The software will automatically load the latest configuration profile. If there are no errors, click Start Configuration. For the first time connecting to this servo, we'll need to check the I/O settings. Make sure there are no enable signals configured. Just click Batch Clear. Now we're going to auto-tuning. Start by selecting the load type that best suits your actual setup. In this case, we are using stiff load. Then set the stiffness. You can stick with the default or choose a different stiffness level. The higher the level, the stiffer the response. For the inertia ratio, just use the default. If you don't need auto-tuning, check Do Not Tuning. Then we go to the next step. Now define the start and end positions. Then set the jog velocity and jog acceleration deceleration. You can use the jog buttons to help locate these positions. Once the positions are set, click Write to Actual Position. Then, define the operation speed, operation acceleration and deceleration, as well as the stop time. Before starting the tuning or using jog, remember to enable the servo drive. Now start tuning. Here in the Auto Tuning Progress screen, you can compare parameters before and after tuning. On the right, you'll find stiffness adjustment and advanced parameters. If you're not satisfied with the result, you can manually tweak the settings based on your needs. Wait until the process finishes. Once done, the software will show whether the tuning was successful and how long it took. The result depends on whether the selected load type matches your actual setup and whether the stiffness and inertia ratio are close to the actual values. Click End to complete the process, and don't forget to save. That's all for the auto-tuning in KincoServo Pro. Next, we'll go through each gain adjustment parameter, so you know how to use them. The notch filter helps suppress resonance by reducing the gain around the mechanical resonance frequency. It can be set manually, or you can use features like online resonance frequency monitoring and adaptive notch to quickly detect and suppress vibration. Simply enable the notch filter, then set the filter parameters, including frequency, depth level, and width level. If you're unsure of the frequency, adjust the load so that the system operates within the resonance range and monitor the actual current on the oscilloscope. Tweak the notch filter and see if the resonance disappears. Command filtering smooths the target commands by removing unnecessary high-frequency components, filtering out anything above the set cutoff frequency. Set the filter parameters, including vibration frequency attenuation level and gain. Then, enable low-frequency vibration suppression. Input Shaper can reshape the smooth target velocity command. This eliminates residual vibration caused by low mechanical stiffness after the positioning process. ZV Shaping for applications requiring fast vibration suppression. It eliminates residual vibration in a short time. ZVD Shaping improves robustness over ZV Shaping, handles system changes better, and offers smoother control response but with longer delay. EI Shaping offers higher robustness, ideal for vibration suppression across a wide frequency range, adapting to various resonances and load changes, but with longer delay. First, select the Input Shaper. Use an oscilloscope to capture the motor position following error or observe the load end vibration to obtain an approximate vibration frequency, then enter the vibration frequency, and gradually increase the damping ratio from 1 until the vibration is completely eliminated. Feed-forward adjustment includes position loop velocity feed-forward and position loop acceleration feed-forward. Increasing velocity feed-forward reduces position error and speeds up response, but may cause overshoot during acceleration and deceleration. For flexible loads, reduce appropriately to avoid oscillation. For rigid loads with persistent vibration, gradually lower the default 100% value. For position loop acceleration feed-forward, usually no adjustment is needed, but can be increased for faster response. Other filters can reduce feedback path noise, such as encoder resolution noise. We have first-order filter, which offers fast response but weaker high-frequency noise suppression. Second-order filter with better high-frequency suppression, but more feedback delay and observer feedback, providing speed feedback even without an encoder. Set the speed feedback mode. Choose whether to enable speed command filtering, and finally set the filter frequency. The smaller the feedback filter frequency, the smoother the waveform, but the greater the feedback delay. Now, let's see how the auto-tuning benefits in the actual application. Enable the driver and start tuning. Thanks for watching. If you have any questions, feel free to contact us.